So here we have three relations, R1, R2, and R3, and each of them are defined on the set A, having the elements A, B, and C. Our goal will be to verify whether if each of the relation is reflexive, symmetric, or transitive. Okay, let us begin with the first one. So here, let's try to understand the problem before going to the first problem. So here we have some relation. So here we have the relation R1, and R1 is defined on the set A. The moment we say that R1 is defined on the set A, this simply means that R1 is going to be a subset of the Cartesian product of A with itself. That is the meaning of that is the meaning when we say that a relation is defined on some set. Okay. Now, what is the Cartesian product of A and A? It's a set containing ordered pairs having nine elements, or we can say 9 ordered pairs. So that will be, so here we are trying to define the Cartesian product of A with itself. That's going to be A comma B, then we have A comma C. So this is the Cartesian product of the set A with itself. Now, when we are defining some relations, these relations are going to also contain some ordered pairs, and it must be true that these ordered pairs must be same as some of the ordered pairs that are present in the Cartesian product of A with itself. Okay, now beginning with the first problem, we have R1. So R1 here contains the element A comma A. We have A comma B. We have A comma C, B comma B, B comma C, C comma A, C comma B, and C comma C. Fine. As we can see here, all of these elements, so we have a total 1, 2, 3, 4, 5, 6, 7. We have a total of 8 elements. All of these 8 elements are present in the Cartesian product of A and A. So that means here we can say that R1 is definitely a subset of the Cartesian product of A and A. So R1 is definitely a relation on A. But our goal here is to not show that it's a relation. It's indeed a relation. Our goal is to show here that the relation is which one of this? Is it reflexive, symmetric, or transitive? That is what we need to show here. Okay. Now, since A has got 3 elements, A, B, and C, so it is necessary that the relation R1 must contain A comma A. This must belong to R1. Is it present? Yes, it is present. Then we have B comma B. This is present in R1 as well. And then we have C comma C. This ordered pair is also present in the relation R1. Now, since these 3 ordered pairs are present in R1, now we can say that this implies that R1 is reflexive. It is definitely going to be reflexive in nature. Okay. Now, what about symmetric? Now, symmetric says that, now let's try to check the first ordered pair A comma A. So if A comma A belongs to R1, this implies, that means what we have to do, we have to interchange the position of the elements in the ordered pair. Then we get A comma A, that must belong to R1. Now that's true. It's A comma A is already present in R1. Fine. Next, if we take the element A comma B, so if we say that A comma B belongs to the relation R1, is it true that B comma A belongs to R1? So we have to check whether if B comma A belongs to R1. Now we see here that there is no such ordered pair, which is B comma A. So here B comma A does not belongs to R1, and that's telling us that our relation R1 is not symmetric. This is not a symmetric relation. Fine. Okay. And then our next goal will be to verify whether if it is transitive. So we consider, let's say, the ordered pair B comma C belonging to R1, and we take the ordered pair C comma A belonging to R1. Now we have to be extremely careful when we choose 2 ordered pairs while testing for the transitivity property. So here we have to make sure that the second element of the first ordered pair and the first element of the second ordered pair, they must be the same. So here we have C, that is the same here. So this must imply that B comma A must belong to R1 as well. Now, do we have an element B comma A present in R1? No, that's not present. Since it is not present, so this tells us that R1 is not transitive as well. So that means in this case, R1 is only going to be reflexive. This is a reflexive relation. It's neither symmetric nor transitive. Okay, let's go to the second one. Now we have another relation R2 containing four ordered pairs AB, BA, AC, CA. First, we are going to check for reflexivity. So we'll check whether if R2 is reflexive or not. So we always have to consider the original set A containing three elements A, B and C. So as we have already mentioned, for any relation to be reflexive on the set A, the ordered pair A, comma A, B, comma B and C, comma C, that must be present. Now clearly here A, comma A does not belongs to R1. We have B, comma B not belonging to R1, and we have C, comma C also not belonging to R1. So we can straight away say that our relation R1 is not reflexive. This is not a reflexive relation on A. Next, we will check for symmetry. So we'll check for symmetry. Now let's say if we check, we will consider the first ordered pair. So if A comma B belongs to the relation R2, or we're talking about R2 here, so this is R2, R2 is not reflexive. This must imply that B comma A is also present in R2. Is it present? Yes, definitely it's present. So this confirms that A comma B and B comma A is present in the relation R2. Next, we're going to consider A comma C. So if A comma C belongs to R2, then it must be true that C comma A is present in R2 as well. Or in other words, you can say if we consider C comma A, then the A comma C must be present, and since it's true, therefore we can say here, hence we can say thus our relation R2, this is going to be symmetric relation. R2 is going to be a symmetric relation on the set A. Fine. Next, coming to the third one, we need to check whether if the relation R2 is transitive or not. Okay, so here we'll consider the first two ordered pair. So if A comma B belongs to R2, actually here this is R2, R2 and R2, R2, and we have the second order pair B comma A belonging to R2. So we're choosing the ordered pair in such a fashion such that we have the second element of the first ordered pair and the first element of the second ordered pair. They must be same. Then this must imply that A comma A must belong to R2 as well. However, this does not belong to R2, and it tells us that R2 is not transitive. This particular relation is not a transitive. This is not a transitive relation on the set A. Okay, so here we have shown that the relation R2, it's only symmetric. It's neither reflexive nor transitive. Now we go to the third relation. Coming to the third relation, we have three ordered pairs A comma B, B comma C and C comma A. Is it reflexive? From first glance, we can say that R3 is not reflexive. This is not reflexive, as we can say that A comma A, B comma B and C comma C, these three ordered pairs does not belong to the relation R3. That's why it is not reflexive. What about symmetric? Okay, let's check. As A comma B belongs to R2, but B comma A does not belongs to R3. We're talking about R3, relation R3. This simply implies that R3 is not symmetric. This is not a symmetric relation on A. This is not symmetric. And then finally, we'll check for transitivity. So what we'll do? For A comma B belonging to R3 and B comma C belonging to R3, A comma C does not belong to R3. So this implies that R3 is also not transitive. This is not transitive relation on the set A. So here we have shown that the relation R3, this is neither reflexive nor symmetric, also not transitive on A.